Hello students. So this video is all about the sodium borohydride reducing reagent. Sodium borohydride NaBH4. So this sodium borohydride is less reactive and a milder hydride reducing agent. Reduction can be carried out in alcohol or aqueous solution provided it is alkaline. Now this NaBH4 is less reactive. It is not strong reducing agent. It is milder reducing agent. Lithium aluminum hydride was what? Strong reducing agent. But this sodium borohydride is milder hydride reducing agent. And it is less reactive. Reduction can be carried out in alcohol or aqueous solution provided it is alkaline. Reduction can be carried out by refluxing aldehyde or ketone with NaBH4 in methanol or ethanol. So for the reduction, what we have to do? The reflux of aldehyde or ketone with NaBH4 in methanol or ethanol. So methanol or ethanol we can use as a solvent. So that will reduce the aldehyde or ketone. Now let's see how this reducing reagent works. Reduction of aldehyde and ketone. So NaBH4, right? So this Na have positive charge and this B have negative charge. Boron have negative charge. So this hydrogen atom from BH4 will attack on this carbonyl carbon atom C double bond O. So that bond will get break and oxygen will have negative charge. Right? So first step is what? Addition of hydrogen atom to the carbonyl group. So we will get this product. Now what will happen? This will react with water molecule. So this negatively charged oxygen atom will form bond with hydrogen atom. And this OH bond will get break. OH minus and Na plus will get eliminate and we will get final product as a alcohol. So basically this NaBH4, right? So the hydrogen atom from NaBH4 will get attached to this carbonyl atom. So first step is what? Addition step, in which addition of hydrogen to carbonyl group will take place. And second step is what? Protonation of that negatively charged oxygen atom. And byproduct is what? NaOH. So this is the mechanism how that NaBH4 reduces the aldehyde and ketone. NaBH4 reduces an aldehyde into primary alcohol and ketone into secondary alcohol. Same as we have seen lithium aluminum hydride reduces aldehyde into primary alcohol and ketone into secondary alcohol. So as we can see, 2-methyl propanol. So this we have taken aldehyde as a reactant. So this NaBH4 will reduce this carbonyl group to what? Alcohol, and we will get 2-methyl propanol. So this aldehyde will get reduced to primary alcohol, and ketone will get reduced into secondary alcohol. Now see the different properties of NaBH4. So NaBH4 is what? Less reactive and more selective. Always remember, those reagents which are less reactive are what? More selective. Less reactive reagent, so it will be more selective. So it can selectively reduce the functional groups. If the reagent is more reactive, then it can react with any functional group. So it will have less selectivity. So always remember, NaBH4 is what? Less reactive. So it will react more selectively. It will reduces the functional group more selectively. So it will reduce only carbonyl group, and it does not reduce other polar groups like nitro group and cyanide group. As we have seen that lithium aluminum hydride in last video, it reduces all polar groups like carbonyl group, nitro group, cyanide group. But this reagent NaBH4, it will reduce only carbonyl group. Remember this. Other polar groups like nitro, cyanide, it will not reduce. And also non-polar groups like alkene, alkyne or arene. So it will reduce only carbonyl group. The reducing action of sodium borohydride, it's so specific that it reduces only carbonyl bond but not the carbon-carbon double bond. So this is croton aldehyde, which contain double bond as well as carbonyl group. So this NaBH4 will reduce only carbonyl group to what? Alcohol. These are the reactions. Benzaldehyde is reacting with NaBH4 to give what? Primary alcohol. So these are the reactions of NaBH4. All three reactants are aldehyde which get reduced to primary alcohol. So let's have a revision what we have seen in this video. First, what you have to remember, sodium borohydride is less reactive, and less reactive means what? More selective. And this sodium borohydride is milder reducing agent, and reduction can be carried out in alcohol or aqueous solution. And reduction of aldehyde and ketone is carried out by refluxing aldehyde and ketone with NaBH4 in methanol or ethanol. And this is the mechanism. First step is what? Addition of hydrogen atom from NaBH4 to carbonyl group of ketone or aldehyde. And second step is what? Protonation of that negatively charged oxygen atom. NaBH4 reduces aldehyde into primary alcohol and ketone into secondary alcohol. This is NaBH4, which is less reactive, more selective, and reduces only carbonyl group, not other polar groups like nitro and cyanide group, and not other non-polar groups like alkene, alkyne or arene. And these are the reactions.